This we are continuing the numerical of force and laws of motion, and as per Harith, we will first start with the given data. So what are the given data? Tell me the given data. So these are the given data. Mass of automobile, that is m, equals to 1500 kg. Final velocity, because the vehicle has finally come to rest, so v, final velocity is denoted by v, is equals to 0, and acceleration, as it is given, negative acceleration, that we also known as deceleration. Okay, so I can write here deceleration, that is 1.7 meter per second square, that is s to the power minus 2. So which formula we will use? What is the formula that we will use to solve this problem? Can anyone say the formula? Tanmay is saying Newton's second law, Harit is saying F equals to ma. So both are correct. Newton's second law is F equals to ma. So we will put the formula from Newton's second law, that is force equals to mass into acceleration, and we will apply the formula just equal to under the previous equal to we will get the force as 2550. So but this cannot be considered as final. One more line we have to add here, otherwise our half marks will be deducted. Last line we have to culminate the answer as hence the force between automobile and the road is minus the 2550 Newton in the opposite to the motion of automobile. So this will be our final answer. Okay. Moving to the next question. Check this, we have done or not. Two objects, each of mass 1.5 kg, are moved in same straight line, but in opposite direction. The velocity of each object is 2.5 meter per second, that is second to the power minus 1, before collision, during which they stick together. What will be the velocity of combined object after collision? So what will be the starting statement? How we will start this? We will start with the given data. So what are the given data? So these are the given data. Mass of object 1, m1, mass of object 2, m2, velocity of object 1, v1, velocity of object 2, v2. Negative sign here indicates because m2 is moving in opposite direction with respect to m1. Okay. Now after this, what we will do? What to do after this? It is saying that before collision, after collision, they will stick together. So what are the criteria after that? What will happen if they stick together? If they stick together, what will happen? So after collision, the two objects stick together and total mass of the combined object will be m1 plus m2, but the velocity will be single because they stick together, the velocity will be single. Okay. Now which formula we will use? Which formula we will use? Which formula we will use? Tell me the formula. Tell me the formula. Harit and Kalp both are wrong. Formula. Yes, now Harit has given the correct answer. The formula will be law of conservation of momentum. So total momentum before collision m1 v1 plus m2 v2, or we can say the previous formula, and after collision single velocity is there, so we will use only the letter V. Okay, now put the formula and tell me the answer. Put the formula and tell me the answer. So Harith has got the answer, but the answer is wrong. We have to find the final velocity after collision. Velocity of combined object after collision. Anyone else? Harith has given another answer that is also wrong. Tanmay has got the correct answer. So the final answer is the velocity of combined object after collision is 0. Okay. So this is the correct answer. Write down in your copies because we have to do the numerical in higher classes also. So we must do the practice from now. Tell me after the completion. So I should write the next question. After completion, write in comment box completed or not. Harith has completed. Rest. So can we move to the next question? Can I wrap the previous question? So this will be our question number 3. So here is the question. A hockey ball of mass 200 gram traveling at 10 meter per second is stuck by a hockey stick so as to return it along its original path with velocity at 5 meter per second. Calculate the change of momentum occurred in the motion of hockey ball by force applied by the hockey stick. So first step, what is the first step? How we will start the solution? This you should do the practice of how we should start the question, how we proceed the question. Okay. So what will be the next step? Given data, very good. So given here is mass of hockey ball, velocity of hockey ball, initial momentum, the final velocity of hockey ball, and final momentum that we have to find out. Initial momentum and final momentum we have to find out. So tell me the next part, what to do now. What will be the next step? Just write in chat box after what you have solved. I think this you have done. Change in momentum m1 v1 minus sorry mv1 minus mv2. M is common, so we have taken common. Then we have solved the velocity difference. Now the doubt is here, why we have not taken final momentum minus initial momentum. The question is, why we have not taken final momentum minus initial momentum. We have taken here initial momentum minus final momentum. Because the question is given, a hockey ball is traveling, means already it has a motion. Okay. And after a while, it has occurred a different velocity. So I think if the motion is started from rest and attained a particular velocity, then we can do the final minus initial, but earlier only it has a particular velocity. So we have taken the change in momentum as initial minus final. Okay. So before solving the numerical, we should read the question very carefully. So write it fast. We should make a target of 5 questions at least in every class. Because if you will do the final minus initial, you will get the value in negative. There only you will understood that you have done the wrong direction momentum. Okay, you have done the calculation in different opposite direction of momentum. That is why while solving the question, we should be very careful that the momentum should not be in negative. Okay. Done, everyone? Next, I think we have question number 4. So this is your question. How much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls from height 80 centimeter? Take the downward acceleration as 10. So we will again start with the same format. Solution, then given. So what are the given data? So here is the given data. Mass of dumbbell, distance covered by the dumbbell for the fall, acceleration the dumbbell used for falling, velocity, initial and final both. Okay, velocity, initial and final both. So after this, which formula we will use to solve this question? After this, which formula we will use to solve the question? So Tanmay is saying third equation of motion. Anyone else? So Tanmay and Harit both are correct. We will use third equation of motion, that is v square equals to u square plus 2as, and we will put the values, that is v square and u square, not v2 u2. Okay, we will put the values and take out the answer. So Kalp has got the answer. Is it correct? Tanmay has got different answer. Kalp has got different answer. Harit has got different answer. Three answers I have got. All three are different. So let's see the answer. The answer is finally 40. The V will be 4 meter per second. Hence the final momentum of dumbbell hits the floor is mv, mass into velocity, that means 40 kg per meter, kg meter per second. Okay, so